Hi, welcome back. So I'll be uploading video solutions for the questions in the recently hosted Math Wiz Quiz 4, which is basically a collegiate math contest simulation. So this is the first question in the easy round. So we have here the set S as a set containing all three-digit permutations of the number ABC, where the ABC are distinct non-zero digits. The sum of the first five elements of S is 2,581. The question is, what is the smallest possible element of S? Now, this involves some parts, but I think before we can answer this one, we have to discuss first some simpler cases. If you are already familiar with digit permutations, and you might want to skip the first part and then just proceed to the particular solution for this video. But for those who are not yet familiar with this topic, then this is for you. So let's consider the simple case. Let's say that we're looking for the sum of possible permutations of the number 25. There are only two possible permutations of this. That's 25 and 52. And their sum is 77. That's pretty easy. For two-digit numbers, it's basically easy. Let's consider cases for three-digit numbers. Let's say we have 257 and we want three-digit permutations of this. So the possible permutations are 257, 275, 527, 572, 725, and 752. Now let's add them. If we add them, and if it's up to you to do this, we get 3,108. So this is still quite simple for three-digit numbers because we only have to list six. But if, for example, we're looking for four-digit numbers, 2579, it becomes more or it becomes more difficult to list all the possibilities. So let's think about how to figure out finding the sum without listing the possible permutations. So to do this, we have to first think about the possible placements of each digit. For example, the digit two. The digit two, sorry, I erased the previous one. The digit two can be placed in the first digit, the second digit, and as the last digit. Yes. So let's say that we consider first the placement in the units digit. Let's say the first digit is 2. The question is, how many instances do we get 2 as the first digit? Now, this is pretty straightforward if we're familiar with the fundamental counting principle. From the fundamental counting principle, we just have to multiply the number of possibilities for the second and the third digit. For the second digit, since we're only looking at three possible choices of digit and one of them is already fixed at 2, then there are only um, two possible cases for this second digit. And for the last digit, we only have one, since the digits cannot be repeated. So the total number of cases where 2 is the leading digit is equal to 2 times 1 is equal to 2, which is evident here. Because from here, we see that we only have two cases where 2 is the leading digit. If 2 is the middle digit, we also get the same number of cases. That's 2 times 1, which is also 2. So we also have this 2. Oh, oops, sorry. We have this 2 as the cases where we have the middle digit. In other words, 2 can be placed um, 2 can be placed as the leading digit twice, as the middle digit twice, and as the last digit twice as well. So for the digit 2, we have the possible sums um, of those numbers is 2 times 100 plus 10 plus 1, where this is for the leading digit tens digit, and as the units digit, leading or hundreds. Gets. So again, we counted the number of possibilities of two showing up in each cases. Sorry, in each case. So that's 2 times 100 times uh and 2 times 1. Now note that if we do it for, or if we examine 5 as well, we get the same number of cases, which is 2. So that's 2 times 100 plus 10 plus 1, and then 2 times 100 plus 10 plus 1. And this is for the digit 2. This is for the digit 5. This is for the digit 7. So if we try to write them all, we get 2 times 100, oops, sorry, 100 plus 10 plus 1 plus 5 times 2 times 100 plus 10 plus 1 plus 7 times 2 times 100 plus 10 plus 1. Of course, 100 plus 10 plus 1 is just 111. So if we factor out this 2 times 111, we get something like 2 times 111 times 2 plus 5 plus 7. So if we perform that operation, that's 2 times 111 times 2 plus 5 plus 7, we get 3108 as we have previously obtained. Okay, you get it? You get it? So it doesn't matter actually if the digits here are 3, 6, and 9, because for each digit, they have two possible positions. So the formula for this one, for 369, would be 2 times 111 times 3 plus 6 plus 9. Okay? You understand? You understand? Now, this is quite a simple case, and this can get more complicated if, for example, we have repeating digits in the possible permutations, and also if we have zeros in that pool as well. So that's the advanced level, and as a practice for you, I want you to try and answer these related problems. Some of these are a bit more difficult. So if you need any help, just let me know in the comments or drop me a message and I can help you with the solutions. Okay, so now let's look at the actual problem that we have. So if we go back to the example we did earlier, we note that for a three-digit number where the digits are distinct, the sum will be 2 times 111 times the sum of the digits. So for the given problem, since the digits are A, B, and C, the total sum is digit sum, digits, oh, sorry, what do you call it? Let's just call this N. N equals 2 times 111 times A plus B plus C. So if we simplify this, we get 222 times A plus B plus C. Now, unlike the example we had earlier, we do not know what the digits are. Actually, that's kind of the goal for the problem. Now, what's important here is that the sum of the digits, or the sum of all possible elements of S, is divisible by 222. So the goal now is to find what that sum is. So since we are given that the partial sum of the 5 elements is 2581, let's think about um, the closest multiple of 222 to 2581. And we can do that by looking at the quotient of 2581 and 222. So that's something maybe like, so since if you're doing this by hand, you just have to estimate. The closest estimate I can think of in mind is maybe 10 or 11. So let's say maybe 11. 222 times 11 is 2222222. 2442, which is less than 2581. So that's definitely not what we want. So to find the other possible multiples of 222, you can multiply by 12, which takes a longer time than just adding 222 to the to what we got earlier, to 2422. So if we do that, we get 2664. So if we subtract 2581 from 2664, we get 2664 minus 2581, we get 83, which is not a three-digit number. So that's not what we want. Because because the remaining here, the difference of these two should give you the missing three-digit number from S. Since it's just two digits, this means that this is not the right sum. We can continue adding 222 plus 222. We get here 2888. Again, we subtract 2581. We get 305. Oh, sorry, that's wrong. We get, what am I doing? We get, sorry, we get 307. What? My arithmetic is not doing well. This should be 6. We get here 2886 minus 2581. We get 305. So this is still not what we want. So again, we add 222. We get here um, 3108 minus 2581. We get here 527. And this is possible because it does not have a zero and all the digits are distinct. So this is a possibility. So I leave it up to you to check the rest. But the complete list is 83, 305, 527, and then um, 749, and then 971. These are the possible three-digit numbers. So the question now is, are all of this valid for the particular problem? The answer is not necessarily. So to check if they are indeed valid, we have to check if the sum of these digits, of the digits of each number, is actually equal to the quotient that we want. Sorry, what can I say? The number that we multiply to 222. For example, 527, the digit sum of this is 14. This is 20. This is 17. So if we multiply 222 times 14, we get 3108. So this is correct. Meanwhile, for this two, this will not give you the numbers that we obtained in the process. So not all of these three are valid, and only 527 is the valid number among these possible numbers. Is that clear? Or is it a bit confusing? If it is confusing, let me know in the comments, please. So to answer the question is, what is the smallest possible element of S? So we know that 527 is the missing element. So the smallest permutation of that is 257. So the answer for this question is 257. 257. And that's our final answer. So I hope you learned something from this video. I'm sorry it's quite long because I tried to explain the first part. I'm not sure if you find this question easy, but it's I don't know if it's not that hard, I think, but if you're not familiar with the topic, then it might not be that easy as well. Anyway, thank you for watching and see you on the next one. Bye bye.